Today I'm going to discuss about laws of motion. It is a very simple topic, and this chapter is there in class 9th also as well as in class 11th. Laws of motion. Any object comes to motion when any external force is applied on it, and the force should be unbalanced. If the net force applied on any object is zero, then the object will not move. So to understand all these concepts, we require to understand what is force at first. So in our junior classes, we had studied about force to be push or pull, but we'll know in more detail what force is. Force is the time rate of change of momentum. Now, what is momentum? Momentum is nothing but product of mass and velocity. So if any object is at rest, so its initial velocity will be 0 and starts moving with a velocity v with some value v is equal to v and reaches to a particular distance at an interval of time t, and the mass is m, then its initial momentum p1 will be m u, final momentum will be p2 mv, and change in momentum delta p will be p2 minus p1 will be mv minus mv, and rate of change of momentum will be delta p by delta t is equal to mv minus mu by t. Here we can take mass as common, v minus u, by change in time we can write delta t. So it comes out to be mass into acceleration, because v minus u by t is equal to acceleration. So we can say that force is nothing but rate of change of momentum is equal to mass into acceleration, and it is a vector quantity. It has both magnitude and direction. So there are three laws of motion. First law says an object at rest or in motion remains at rest or motion until any external unbalanced force acts on it. Second law of motion says the rate of change of momentum is directly proportional to the force applied on the body. That means force is directly proportional to the rate of change of momentum, or we can write delta v by delta u, delta v by delta t to be as acceleration. This arrow shows it is a vector quantity. So we can write F is equal to some proportionality constant K, which can be called as force constant, mass into acceleration. This was what was derived in the previous slide. The third law of motion says every action has opposite and same reaction. That means if somebody is climbing upon stair, then moment the person will step up or will press his foot down, he will climb up. Similarly, while rising up in a rope, the body has to be pulled down to the rope has to be pulled down to make the body climb up. In case of a catapult, the stone can be thrown by pulling the elastic backward and releasing it. As a result, the stone will fly on the other side. In case of, say, an arrow, the more the arrow is pulled backward, the faster it goes ahead. In case of birds, the bird which will flip its wing downward will experience a reactionary force and will go upward. Now, the flipping of the wing downward will make the bird move, fly upward. So whenever we apply force on a particular direction, there is a reactionary force which acts in the opposite direction. So these are the three important laws of motion. Now let us try to understand the importance of these laws of motion by solving one small numerical problem. The problem says that an object is pushed. An object is pushed with an angle 60 degree on a plane surface. So there is a person who is pulling or who is pushing the object at an angle 60 degree with a force equal to, say, 72 dyne. And the mass of the object is 9 gram. So we have to find out what is the acceleration which the object will get in the horizontal direction. So this is a vector. If we resolve this vector, then say if it is O, A, B, then the force acting in the direction OB, to find that out, we'll write OB by OA will be equal to cos 60 degree, or we can write OB is equal to OA cos 60 degree. OB can be written as force in the direction of x-axis, that means horizontal force, is equal to the applied force F cos 60 degree. Now, the acceleration in the horizontal direction AX will be equal to F cos theta will be equal to m into acceleration in the x direction AX. So AX can be written as F cos theta by m. It will be 72 multiplied by cos theta will be equal to cos 60 degree. Value of cos 60 degree is half, and m is 9 gram, and this is 72 dyne. 72 dyne can be written as 72 centimeter gram per second square multiplied by half divided by 9. So this will become 4 centimeter per second square acceleration. So in the chapter laws of motion, we will require to understand about resolution of vector also. So it is very important to understand the numerical or the concept of this chapter. Before that, we should have the concept of motion in one dimension and motion in two dimension, resolution of vector, trigonometry, these concepts very much clear. So I will be bringing up these concepts subsequently so that the student, those who are newly admitted in class 11 science, will feel physics is easy. Thank you.